Deep inside any enterprise network, domain controllers exist in a state of constant synchronization, trading directory updates across localized network links to ensure every server has the exact same map of the organization. The mechanism driving this synchronization is called an intrasite change notification. Intrasite refers to servers located within the same physical Active Directory site. When one domain controller registers a change, like a password update or a new user account, it sends a notification ping to its immediate replication partners to initiate a data pull. These domain controllers do not broadcast changes the millisecond they occur. They deliberately inject delay intervals before sending notifications. This pause batches multiple updates together, preventing the network from being flooded with traffic during mass directory modifications. The methodology dictating exactly how long these delays last and where those timers are stored underwent a massive architectural rewrite between two specific generations of Windows Server. To understand the shift, we start at the baseline, the release of Windows 2000 Server. This operating system managed replication timers using a rigid, monolithic approach, controlled directly by the local machine. Then came the modern counterpart, Windows Server 2003. This release introduced an object-based, granular architecture that integrated the timers directly into the shared directory database. By mapping the exact storage mechanisms of both these operating systems, we can analyze the strict conditional logic that dictates which settings survive when an infrastructure is upgraded from the old framework to the new one. This transition represents a complete, fundamental re-engineering of exactly how Active Directory scopes and enforces system configuration data across an entire enterprise network. The Windows 2000 Server architecture enforced a broad, inflexible scope. Its notification delay values applied universally, affecting all directory partitions globally on a given domain controller. These universal values were not stored in a shared database. They were hard-coded directly into the local registry of each individual domain controller. This diagram outlines the exact path where these legacy parameters are stored. Navigating through the local machine system settings, we drop into Current Control Set, then Services, down to NTDS, and finally into Parameters. Inside this directory, we isolate a specific registry entry, Replicator Notify Pause After Audify, SEX. This entry serves a single function. It defines the mandatory delay a domain controller must observe before sending its very first change notification to its replication partners. In Windows 2000, Microsoft assigned this entry a default value of 300 seconds. Immediately below it sits a second necessary registry entry, Replicator Notify Pause Between DSAs, SEX. This entry governs the pacing of sequential updates. Once the initial notification is sent, this timer enforces a delay before sending each subsequent change notification to any remaining partners. The default value assigned to this subsequent delay entry is 30 seconds. Operationally, forcing a server to wait 5 full minutes before notifying partners of an initial directory change creates a significant synchronization bottleneck, particularly within high-traffic sites where accounts are continuously updated. The Windows 2000 model operates as a monolithic, server-wide governor. It lacks the architectural flexibility to tune delay timers for specific directory partitions. Windows Server 2003 introduced a new design philosophy. It shifted control of synchronization timing away from the local operating system and placed it into the shared directory database itself. Delay settings were rescoped. Instead of applying to the entire server, they became specific to each individual directory partition. This database schema visualization maps the new internal storage location. Inside the configuration directory partition, we find the partitions container. Here, we locate our target entity, the cross-reference object, which stores location data for a given partition. To replace the old local registry keys, Microsoft attached 2 entirely new Active Directory attributes directly to this object. The attribute governing the initial pause is labeled MSDS Replication Notify First DSA Delay. Its default value is aggressively optimized down to just 15 seconds. The attribute managing sequential partner updates is labeled MSDS Replication Notify Subsequent DSA Delay. Its default value is highly compressed, dropping the wait time to exactly 3 seconds. By attaching these new NTDS attributes directly to the cross-reference object, Windows Server 2003 enabled granular, highly responsive synchronization parameters uniquely tailored to the individual needs of each partition. This shift creates a core operational hazard during migration. When an environment is upgraded to Windows Server 2003, the system has to decide what to do with the old Windows 2000 registry settings still sitting on the local servers. The act of raising the forest functional level, a setting that activates domain-wide features once all controllers run a specific OS version, triggers a strict evaluation script to begin. This logical flowchart shows the precise decision matrix the operating system executes during a functional level upgrade. First, the system scans the local NTTS parameters registry hive on each domain controller. Condition A occurs if the system detects the exact legacy default values of 300 seconds for the initial delay and 30 seconds for the subsequent delay. If those defaults are found, the system executes an automated optimization action. It actively removes these default registry entries from the local machine. With the keys deleted, the system falls back to the newly created cross-reference attributes, enforcing the modern 15-second and 3-second defaults. Condition B occurs if the system detects non-default values in the registry. This mathematical discrepancy indicates a human administrator previously customized the delay timers. When this happens, a preservation protocol engages. The upgrade process leaves these custom registry values completely intact. The script aggressively optimizes default environments while strictly respecting and preserving intentional administrator customizations. Understanding this logic is critical for managing a fully deployed, natively functioning Windows Server 2003 environment. Even though modern replication relies on the new database-integrated attributes, the core operating system continues to quietly monitor those legacy local registry paths. This diagram illustrates a modern domain controller actively utilizing the optimized 15-second cross-reference attributes to synchronize. At any point, an infrastructure engineer can intentionally open the local registry and manually add the legacy Windows 2000 entries back into the system. A hard-coded rule of precedence takes over. The physical presence of these specific registry entries immediately overrides the modern cross-reference attribute values. This provides architects with a targeted override. They can intentionally throttle specific, heavily burdened domain controllers by editing their local registries without altering the master replication topology for the entire directory partition. Active Directory evolved from a monolithic architecture into a highly granular, database-driven system. Yet deep in the operating system's logic, the local registry remains the ultimate hard-coded arbiter for intrasite replication timing.